measures of location and spread. So measures of location include the averages, the mode, median and mean, and percentiles. Measures of spread in the data or dispersion in data include range, interquartile range, standard deviation and interpercentile range. When data is not grouped, so if we have a list of numbers, or as I've done here, I've taken this data and put it into a frequency table, you can see there are no class intervals. We have individual data values, so the data is not grouped. So all of the data values are known. Typically we have discrete data in a table like this or in this format, but not always, and the methods involved are straightforward, they are easy. Grouped data would be in a frequency table, so you would get frequency tables like this. What's the main difference between these two tables? They look very similar. The frequencies are identical. The actual values here for the class intervals differ. It's all about rounding data. So in this table the data has not been rounded. In here data has been rounded. Now data here are weights in kilograms. So in this table the data was rounded to the nearest kilogram. So we should look at class boundaries next. So these are the actual class boundaries. Compare them with the original data that I showed here and the class boundaries. So this interval ends on 19, this one starts at 20. There is a gap in between these. There is no longer a gap. So these are the lower class boundaries and the upper class boundaries. So if we look at this class interval, so 10 to 20 kilograms, 9.5 to 19.5 kilograms, there are 7 data values in each, so those data values will be evenly distributed. So here they are evenly distributed between 10 and 20 kilograms, and here between 9.5 and 19.5 kilograms, and there are 7 values in each. And if we're looking for a data value within this interval somewhere, or within this interval, that process is called interpolation. Moving on to class midpoints. So the midpoint here would be 10 plus 20 divided by 2. Here it would be 9.5 plus 19.5 divided by 2. Again, I'm using the lower class boundary and upper class boundary to calculate midpoint. So these are the actual midpoints. But why do we need to use midpoints? Well, if I look at this particular class, there are 19 data values in that particular class. We don't have the original 19 data values. So we estimate all 19 as being equal to the midpoint. All 19 equal to the midpoint. And that's necessary when doing calculations for the mean and standard deviation. The class width, that's an easy one. It's just the upper class boundary minus the lower class boundary, which is 10 for each class in each table. So to summarize, the data values are unknown when we've grouped our data. Typically we have continuous data that's grouped, but not always. We can group discrete data as well. We have to check to see if the data has been rounded. We need to work out class boundaries, class widths, midpoints. We may use interpolation in calculations. Anything we work out will be an estimate because the original raw data is unavailable. And the methods involved are complicated. The methods for ungrouped data and for grouped data differ slightly. So we will look at measures of location and spread separately for each.